Bismillahirrahmanirrahim. I am Hussnain Ali from Bagh School, grade 13 chemistry teacher. Here in this video, we will be going through the question number 7 of mock 2 examination paper 4. In the question number 7, the examiner was saying that the table lists the equation for the 5 processes. For each process, predict the sign of delta S. Here, delta S represents the entropy change. Entropy is basically defined as the disorderness in a system. So we have to see whether the delta S is positive or negative. If it is positive, it means that the disorderness has increased, and if it is negative, vice versa is to be understood. So in the first reaction, NaBr solid plus water is giving sodium bromide aqueous. This shows that the disorderness of the system is increasing as the solid NaBr is converted into aqueous NaBr, which has positive and negative ions. Sodium positive ions are formed while bromide negative ions are formed, which produces more disorderness. So our sign for delta S becomes positive. For the second reaction, water liquid was converted into water gaseous. So we know from our previous lectures that actually when the state changes from liquid to gas, actually the disorderness increases and the entropy becomes positive, as the gaseous water would be having more disordered water molecules. In the third statement, hydrogen was reacting with oxygen and water was formed in gaseous form. So here we have to compare the moles on the right and left side. On the left side there were 3 moles of the gas, while on the right side there were 2 moles of the gas. So from this concept of entropy, we know if the number of moles are decreasing towards the product, the entropy becomes negative. In the fourth reaction, cobalt chloride solid is reacting with water and it is forming cobalt chloride dot 6H2O solid. This is a complex that is formed of cobalt chloride that is solid. So in this reaction, basically if you would see, total 7 moles of reactants are forming 1 moles of product. So it means that the entropy is negative as the disorderness is decreasing. So you can go through your notes also to compare the results that I have given here in the bottom of the slide, that which one is positive and which one is negative. In the B part, the examiner was saying ethanol can be combusted as shown in the equation. This is the combustion equation of ethanol. Standard entropies are shown in the table. For ethanol it was 161, for oxygen it was 205, for carbon dioxide it was 214, for water it was 70 joule per mole Kelvin. So he is asked, calculate the standard entropy for this reaction. For the standard entropy calculation, we know the formula. The standard entropy is equal to entropy of the products minus entropy of the reactants. I've given the answer at the bottom of the slide. You can see that product is basically 2 carbon dioxides. So 2 is multiplied by 214 plus 70 is for the water, multiplied by 3 minus 161 is for ethanol. It is having only 1 mole from the equation. So a net basically minus would be coming with the reactant 205 multiplied by 3 here. 205 represents the oxygen. So we would be getting an answer of minus 138 joule per mole Kelvin. All you have to do is first of all find the entropy of the products and then find the entropy of the reactants. Then you have to subtract the entropy of the reactants from the entropy of the products so as to get our answer in joule per mole Kelvin. In the C part of the question number 7, the examiner was saying the combustion of ethanol is an exothermic reaction. It means the delta H is negative for this reaction. This reaction occurs spontaneously at low temperatures but does not occur at very high temperature. Explain why. If you can see that for this reaction, the entropy that we have calculated is in negative, while its delta H is also negative. So our formula for calculating the spontaneity of a reaction, we use the Gibbs free energy formula, that is delta G is equal to delta H minus T delta S. So in this case, delta H is negative, while the T delta S component becomes positive because delta S is negative. So it will multiplied with the outer negative, it would be forming a positive. So T delta S becomes a positive overall. So our net equation for this reaction becomes is equal to delta G is equal to minus delta H plus T delta S. So by increasing the temperature, the T delta S factor would increase. When the T delta S factor would be increasing, a more positive answer would be coming. It means that delta G would be more positive. It means at that temperature, at higher temperatures, the reaction would be more feasible or more spontaneous. I have given the answer at the bottom of the slide. You can see the answer and compare what I have said. In the D part, the decomposition of calcium carbonate is endothermic reaction. Calcium carbonate gives calcium oxide and carbon dioxide. Calculate the minimum temperature at which the reaction becomes feasible. Show all your working. This has also been previously done in our notes also. Students, you can go through our notes. We know that the delta G has the formula delta G is equal to delta H minus T delta S. Here for the feasibility at which the temperature where the reaction becomes feasible, we have to put the delta G is as 0. So our equation becomes T delta S is equal to delta H, and T could be found by dividing delta H by delta S. So you can calculate T by dividing delta H by delta S, but be careful while calculating. Delta S is first to be converted into kilojoule per mole Kelvin. So we have to divide the delta S value, that is 159 by 1000, and we could get the answer here that the T is equal to here the examiner has done in another way. He has used the kilojoule and he has converted the kilojoule into joules by multiplying 178 with 1000 and dividing the delta S. The other methodology is that you can make the delta H remains the same while converting the delta S to be in kilojoule by dividing it with 1000. So we would be getting an answer of a temperature of 1119.5 Kelvin. That would be a temperature at which the reaction would be feasible in the case of calcium carbonate and forming calcium oxide and carbon dioxide. Hopefully you are finding these videos useful. Take care. Allah Hafiz.